Good morning, children. So, we would continue with our exercise 9.1 up to onwards question number 6 now, 6 to 10. I will be covering within today's lecture. So, here is question number 6. You read the problem again. A 1.5 tall boy is standing at some distance from a 30-meter tall building. 1.5 meter. So BD is the boy. So here I have shown that very clearly. And building I have taken is AF here, which is 30 meter high. The angle of elevation from his eye to the top of the building. Now, if this is the height of the boy, at B the eye position will be there. Then I need to draw the line of sight. That's why you need to mention somewhere you draw BC parallel to DF. That is required so that you will be getting the base to form the angle of elevation of the top of this building in I, and that is equal to what? 30 degree. Now, the angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree. So there is a change in angle of elevation from 30 to 60. How? As he walks towards the building. Now boy is starting walking towards the building from this initial position to this position, suppose. So at this position the angle of elevation comes. So this is again the height of the boy will remain same and the angle of elevation will be equal to what? 60 degree. And I need to determine the distance walked by the boy towards the building. So again you need to write the information. BD is a boy, height 1.5 and AF is a building of height 30 meter. I need to calculate the distance moved by boy. So that is from B to G you can take here. BG I have to calculate from his initial position towards the building. Now I have drawn the diagram here in two ways, and you also need to keep in your mind. This is the possibility that eye position of the, if you want to ignore his height, you can ignore that. Then eye position can be taken at the ground level. So now if you have ignored the height of the boy, then you need to subtract that height of boy from the height of the total height of the building. That I did here. 30 minus 1.5 is equal to 28.5. Because my concern is not there with this part. That's why that I can consider in the building whether you would like to go for this figure or this figure. So you always remember, you don't want to count the height of the boy. Then you need to subtract his height from the total height, whatever is there. Sometimes it is given, sometimes we have to calculate. So in that way you need to draw the diagram, because my total concern in this figure, that is A, B, C and G. So I also can consider here. So I have mentioned everything. Here BD is equal to GE is equal to CF. That is in everywhere height of the boy. As this line is drawn parallel to this line, this will definitely be forming a parallelogram and opposite sides are equal and the distance between the opposite sides are always same. And AF is the total height that is of the building. Now the boy walks from B to G. That is so that the angle of elevation changes from 30 degree to 60 degree, and then these angles AGC and ABC are formed 60 degree and 30 degree, and AC definitely that is equal to what? AF minus FC, and is equal to what? 28.5 meter. So now I need to consider this triangle ABC, you can see here, in which I have to go for the calculation distance BG. So if I just can calculate BC, out of that if I can minus this GC, I will be able to get the length of BG, and that I have to do. So two triangles, building definitely will always be the perpendicular with respect to the ground. So as I already have told it to you, our concern will always be with the right triangle. So you study this triangle ABC. Now the calculations are easy. Here if I am taking this angle, so 30 degrees the angle, so tangent 30 will be equal to perpendicular upon base. Then it will be AC upon BC. AC is given. So AC you need to put here, and from here you can calculate BC and give it number 1. Similarly, distance walked by the boy, as you can see, is BG. This is BC from B to G, BG towards the building, and that if I need to calculate from the whole, that is from BC, so I need to subtract GC from BC to calculate what? BG. That I have written as equation number 2, and to get this BC already I have got here, and to get this GC now I will take another triangle AGC, and in which the angles are given, and again I will apply perpendicular upon base is equal to tangent 60 now. So AC is given, GC I need to calculate. So you will be reaching somewhere at 9.5 into root 3. So 1 is there, 2 second result, and third is the second this result GC. So you just compare these three, 1, 2, 3, and from 1 to 3 you will be getting the distance moved by the boy DG is equal to BC minus GC. So here it is BC and here it is GC. If you subtract these values, you will be reaching at 19 under root 3 meter, which is the answer for this question. Then your question number 7. From a point on the ground, the angles of elevation of the bottom and top of a transmission tower. Read the question very carefully. From a point on the ground, the angle of elevation from a point on the ground, the angle of elevation of the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degree and 60 degree respectively. You need to determine the height of the tower. So I have taken BC as building, and height of the building is given 20 meters. So this much part is of building, and AB above at the top of the building, this AB is the transmission tower. So then from a point on the ground, that point I have taken as D. The angle of elevation of the top of the building, that is B, is equal to 45 degree. And the angle of elevation I just have explained it to you from the lower to the upper part. So from bottom to the top. So here it is 45 with respect to top of the building, and with respect to the top of the transmission tower, it is given equal to 60 degrees. So 60 degrees is this whole angle, that is ADC. So now figure is there. Already I have told you, once the figure is there, your 50% problem is solved. So what you can do is, let us study this triangle ADC, as I have to calculate AB here. So I know BC is available with me. If I will be able to get this DC, I can apply that AC upon DC in whole triangle ACD, and comfortably I will be able to get the value of this AB then. So what I did, in triangle ADC, easily I can go for DC. Why? Because perpendicular upon base is equal to tangent. 45 is 1. So BC 20 upon DC, that will make your this length is equal to what? 20 meter. This is in meter, so 20 meter. And then in triangle ADC, if you see the whole angle ADC is equal to tangent 60, then this perpendicular is now AC. And perpendicular you can understand, again your building and transmission tower are standing with respect to angle of 90 degree. So here this value root 3 AC upon DC. DC now we have calculated here is equal to 20 meter. So AC is equal to 20 under the root 3, and from here height of the transmission tower AB, you can use this equation AC minus BC, and then do this calculation 20 root 3 minus 20, 20 into root 3 minus 1, 20 is equal to put the value of root 3, 1.732 minus 1, 20, do this calculation up to the last. You can see, just to make you people understand how easily we can get it. So finally you will be left with 2 into 732 upon 100, and up to the second place of decimal accurately you can write your answer, and that is equal to 14.64 meter. So just hold on for your question number 8, 9 and 10. I would like to take you to the next class. 8 is a statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60, and from the same point the angle of elevation of the top of the pedestal is 45. Now you have to determine the find the height of the pedestal. Just quite similar to the previous question. In previous part we have calculated this height, and now this is given and this we have to find. In question number 7 it was like this was the building and this was the transmission tower. Now this is the pedestal and this is the statue, and I have to calculate the height of the pedestal. So same procedure we have to follow here. You explain it like write the information very carefully. Say BC is the pedestal, this is the pedestal, and CD is the statue of height 1.6 that is given to you. Then the angle with respect to the top of the pedestal is given 45, and again with respect to the top of the that is statue's height up to this D, that is also given is equal to 60 degree. And then again you write the information, study these two triangles DBA and ABC. So if you will be studying ABC, again your h upon x will take you to tangent 45. In that way you will be reaching somewhere h is equal to x. And then you will take whole the triangle ABD, in which again DB upon AB is equal to tangent 60. So your DB is what? 1.6 plus h. 1.6 plus h whole upon this x is equal to root 3. X already you have calculated is equal to h. So what is the use here? Your this equation from two variables now will be converted into one variable, and some variable which you can leave the equation in one variable to get the value of h. So that height from this, go for rationalization, do the calculations very carefully, and finally by putting the value of under root 3 and all, again comfortably you can write your answer up to the third place of decimal. So your question number 7 and 8, only the positions were changed of your subject, otherwise quite same diagrams were there followed in both these two questions. Now number 9 is the angle of elevation on the top of a building from the foot of the tower. From the foot of the tower is 30 degree. And the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, then you have to calculate the height of the building. So you make it very clear in your answer somewhere in the beginning. So let us say AB is the building and your CD is the tower, and you both are standing with respect to 90 degree to the ground. So AB is the building and CD is the tower. So angle of elevation from the foot of the tower to the top of the building is 30 degrees. You draw that. So one triangle is ready with you, that is ABD, which is a right triangle. And angle of elevation of the top of the tower from the foot of the building. Now if this is the building and this is the tower, so from the foot of the building, the angle of elevation is given equal to what? 60 degree. And then the total height is given equal to what? 50 meters. So now you need to calculate this height. Comfortably you can study these two triangles ABD as well as your triangle CBD. So here the height of the tower is given, so better to go for this option first, that is your CBD. Use this tangent 60, that is the perpendicular upon base, so perpendicular is CD. Here is the angle, so opposite to that is the perpendicular. Back to exercise 8.1, P upon B. So P upon B, CD upon BD is tangent theta. So tangent 60 root 3 upon 50 upon BD, that will take you to the length of the side. BD is equal to 50 upon root 3. Now I need to calculate AB. So study this triangle ABD. So ABD, again, now the angle is here, perpendicular is there. Perpendicular upon base is equal to tangent theta, so it will be AB upon BD. Put the value, tangent 31 upon root 3, AB, BD you have calculated 50 upon root 3. Do the cross multiplication, AB into root 3 is equal to 50 root 3 into 1, that is this. So AB is equal to 50 root 3 into 1 upon root 3. Root 3 into root 3 will make it 3, so 50 upon 3. If you go for this calculation, finally you will be getting the height of the building up to the second place of decimal. At least you should write your answer, and that will be coming 16.67 of meters. Then the 10th question. That is somewhere two poles of equal heights are standing opposite each other on either side of the road, which is 80 meter wide. So I am taking this is the road BD. Total is 80 meter.
I have considered somewhere P is the point from where the angles were observed. So distance of this P from foot of the one pole I have taken is x. So as the total is 80, so definitely the remaining part will be 80 minus x. And both are of equal height, so this is also h and this is also h. The angle of elevation for this top is given 60 degree and for this top is given 30 degree when you go through your problem. And by studying this situation, we need to calculate the height of the poles. So you write it assumption, whatever you are going to do, and according to your own thinking, whatever the figure you are going to draw after going through the problem. So I said let AB and CD be the poles and of height h meter as the height is equal. So for both I have to write the equal height, and P is the point from where I am observing. So this is not a condition you have to take 30 degree to this side or to this side only. This is not mandatory. If you are taking 30 this, you can go for that, then this will be 60 degree. If you are taking this much is equal to x, then you can take this is also equal to 80 minus x. Will not make any difference in your calculation part. Then you study these two triangles. Now this is the information I am getting. So BD is equal to 80 meter total. So I will write that 80 and 80 minus x. So if I study this triangle ABP, perpendicular upon base h upon x will take me to tangent 60, and my h will be there. Now definitely I have two variables, h and x in both. So try to work out within one variable. Make the one variable as a subject as I did, either in terms of h or in terms of x. So I use h. So in first triangle also I have gone for h, and in second triangle also I have gone for h, so that I can equate these two equations. So finally I have gone for 1 and 2, and by equating these two equations, now I can express these in terms of x, and then do the cross multiplication. Your answer number 1 will be there, that is x. Put the value of x here in 1, so you will be getting the value of h, and then finally put it here, you will be getting the third answer also. So all three answers at a time simultaneously you can write, and that is the solution for your question number 10. So that's all from my side for today. So tomorrow I would like to begin with your exercise 9.1 onwards question 11. Till then, bye bye. Thank you.